Hey guys, welcome back to another coding challenge video. It has been a long time, but I'm back, and today we're going to be looking at the insert a node at the tail of a linked list problem from HackerRank, and we'll be doing it in C#. So this one has a pretty descriptive name. You probably already know what it's about, but basically we're going to be inserting a node at the tail of a linked list. If you don't know what a linked list is, just hold on, I'll talk about it in a second. So more or less, we're going to be given an integer called data, and then the head of a singly linked list. And so the idea is that we want to first make a node containing the data given, and then we want to figure out where the end of the list is, given the head, and we want to throw that node on the end and then return the head. So we'll be given the head and we'll be returning the head. So another important thing to note is that the given head pointer may be null, meaning that the initial list is empty. So in that case, we're pretty much going to be returning just the node that we made, being the only thing in the list. So then it goes on and tells us that we don't have to worry about printing anything out to the screen. We don't have to worry about reading anything from the console. So let's look at our constraints and we'll just continue on with it. So our constraints are going to be n, which is the number of things that we have to add to this. We don't really have to worry about this. And then something else that's given in our constraints is list at I, which they're basically saying the numbers to insert, the numbers in the list are guaranteed to be between 1 and 1,000. So nothing too crazy going on here. You don't have to worry about any abnormal data types or anything like that. So yeah, let's talk about for a second what a linked list is and what a singly linked list is. And for that, let's draw a picture. So a linked list is comprised of these things called nodes. So I'll just go ahead and draw these nodes as circles. So each of these nodes holds some sort of data. The data can be anything. In our problem, it's just going to be numbers. So I don't know, they don't have to be in order and they don't have to, well, I guess our problem says they have to be between 1 and 1,000, so. But it does not matter what they are. A linked list can be ordered, but it can also not be ordered. So the other important thing besides the data is that they have what's called a pointer. And a pointer, won't talk too much about what that is exactly in this video, but basically each node points to another node. And in that way, they are linked. The last node points to null. It doesn't point to anything. So the first node keeps track of where the second node is. The second node keeps track of where the third node is, so on and so forth. So this right here is what's called a singly linked list, meaning that it only has a single pointer. Another common thing is called a doubly linked list, in which case the node not only keeps track of the next thing, but it keeps track of the previous thing also, like this. And so, you know, if you're at a node where the previous pointer is null, then you're at the head. And if you're at a node where the next pointer is null, then you're at the tail. So we don't have to worry about this in this problem because we're dealing with a singly linked list. And so the idea is we'll first be creating a node with whatever data they give us. And remember, this has a reference, which we'll set to null because we know that this will eventually become the end of the list. So the next thing that we need to do is we're given the head. This is the head, the first thing. And we want to figure out where the tail is. So in order to figure out where the tail is, we'll pretty much just be following this trail of next pointers until we get to null. And we know that once we get to null, we're at the tail. And so we'll set this pointer to point to this node therein making this the last node. So in order to do that, we just have to make something that can point, at least temporarily to each of these nodes. So let's say like current node. And initially we'll say head. So we'll say if the current node's next pointer, which is this guy, is not null, then we'll set the current node to this guy, to the next node. And then we'll check it again. What's the next pointer looking at? Well, 1000. And that's not null, so we're not at the end. So let's set it to the next one. And so on and so forth until we get to this guy right here. In which case we'll say, what's the next one? Null. Okay, well, instead of saying null, let's get rid of you, and then we'll say point to this one right here. And then we'll just return the head. And that is pretty much the whole idea behind this algorithm. So let's code that up. So first off, we need to make our new node. And that's going to be of type singly linked list node. Now this is not a standard data type, which is why they've put this note here saying what it is, because this is a custom data type that they've put in just for this problem. So we can say it's comprised of an integer that they call data, and then within itself, it has a reference, an object of the same type, a next node. Okay. And in general, in C#, any sort of custom data type can always be null. So next can be a node, but it can also be null. So keep that in mind because that'll come in handy in a second. But we'll just call this node, and we'll set it equal to a new singly linked list node, and we'll be giving it data. So the way that I know that you can give it data is because I already coded up this problem, and what they didn't tell you in this note, which would have been nice, is that there's actually a constructor that looks like this. And there's actually no other constructor, so if you try and construct this with nothing, it'll get mad at you. So that's the way you're gonna have to do that. Would have been nice to include this 4 more lines in the problem statement, but whatever. I'll save you that 10 seconds of your life. And so what are we gonna be returning? Well, usually we're returning the thing that we create, but in this case, we're actually returning head after we make some modifications to it. So the first thing we have to check is if head comes in as null, meaning the list is blank. So if head is null, then we can pretty much just say that head is equal to the new thing that we created. Or we could just say return node, whatever you want. I like to have as few return statements as possible. There's a good tip for you. Whenever possible, try and have as few return statements in your code as possible. And when possible, try and make them somewhat close to each other. And that's kind of just good practice because it's easy to see how a function exits. That makes sense. How it returns. Okay, so if that's not the case, then we need to figure out where the end is. And to do that, if you remember, we'll make some sort of thing called current node, which will keep track of what current node we're looking at. So to initialize this, we'll pretty much just say it's equal to head at the start, because we want to start at the very first thing. And then we want to pretty much keep moving through the list until we reach a node whose next node is null. So because we don't know exactly how many iterations that's going to be, that's pretty much indicative that we're going to be using a while loop. While loop Whenever you don't know how many times you're going to have to do something, while loop is pretty much the way that you're going to go with that. And so we're just going to say while the current node that we're looking at, while the next node is not null, then we'll keep moving through the list. So current node is equal to current node next. So just set it equal to the next thing, and then it'll keep going. Okay, so whatever current node I'm at, is the next thing null? No. Okay, go to the next one, and so on and so forth. So we know that when the while loop exits, by the time we get here to line 80, we know that we are at a node whose next node is null. In other words, we're at the end. So then, if you remember from our drawing, we'll have to kind of, instead of having this last node point to null, we'll just say the next node is equal to the one that we created. So we'll say current node next is equal to node, node being the thing that we made up here. And so that is all we have to do. Head will be modified because we've gone down the chain and then added it. And so we can just get away with returning head. And yeah, let's test this and make sure we didn't spell anything weird or... Cool. Let's run it against all the test cases. Awesome. So yeah, hope you enjoyed the video. There's a whole bunch of linked list problems on HackerRank, and so I'll probably be doing a few more of those. But as always, if you have a better way to do this, or if you have any suggestions or requests, just feel free to comment below or send me a message. Thanks for watching.